Okay, so now we look at preparations of alkyl halide. Okay, preparation of alkyl halide means that we want to produce alkyl halide. Okay, we want to produce alkyl halide. So the starting material for the reactions to produce alkyl halide differs. So for example, for this preparation, we have two reactions. Okay, the first one is halogenation. Second is hydrohalogenation of alkene. Okay, so for the first one, halogenation, okay, we look at the first reaction. Okay, the starting material is alkane. Okay, the first one is halogenation. Okay, the starting material is alkane. React with diatomic halogen. Okay, diatomic halogen or halogen molecules. Okay, for X2. Okay, X2. For example, Cl2, Br2, F2, I2, for example. So it must be in diatomic. Okay, and then draw the arrow in the presence of UV light. Okay, so this is compulsory. Okay, in the presence of UV light, and it will form alkyl halide. Alkyl halide. Alkyl halide plus the byproduct is HX. Okay. It doesn't matter whether the alkane here is primary alkane, secondary or tertiary. Okay. But the concept is the same, where we just replace the hydrogen with halogen. Okay, so for example, okay, CH3. Okay, so here we have two Cl2, so we expand the structure for the halogen, expand the structure, and then this is UV. Okay, put it like this. Okay, now use another color. Okay, use another color. So remove hydrogen. Okay, we circle hydrogen, means that this will be removed. And then for chlorine, remove one chlorine. Okay, and then we combine it. Okay, so the remaining, do not change the structure for the remaining structure for the alkane. It remains. Okay, now it is no more H, no more, so it will combine with this Cl. So Cl, like this. Okay, and the byproduct is the one that you removed, HCl. Okay, so that's it. This is your alkyl halide, and you can identify the class based on this. So this CH, the H attached, there are two H attached, means that this is primary alkyl halide. Okay, alkyl halide. Remember, for secondary, it's only one hydrogen attached, and tertiary, no hydrogen attached at all. So simple. Okay, this halogenation, usually it is for primary alkyl halide. Okay, primary alkyl halide. Okay, now moving on to the next one is hydrohalogenation. Okay, hydrohalogenation. Okay, for hydrohalogenation, okay, the starting material is alkene. Okay, alkene. Okay, and this alkene will react with hydrogen HX. Okay, hydrogen halide. Okay, HX. HX here, it can be HCl or HF, depends on your halogen. So HI or HBr. As I mentioned earlier, there are only 4 halogen. Okay, so it depends. Okay, so now when alkene reacts with hydrogen halide, okay, we just write it down. The name of this starting material is, the starting material here is hydrogen halide. Okay, hydrogen halide. So the product formed is alkyl halide. alkyl halide. Okay, so it is actually simple, but since this is alkene, okay, so there are rules, okay, applied for this hydrohalogenation. Okay, so here we follow the term here is, okay, we follow direction, so we just write it down first. Hydrohalogenation, there are two directions. Okay, one is we follow Markovnikov's, okay, Markovnikov's rule. Okay, make sure you get it right, the spelling. Okay, and then the second one is anti-Markovnikov. Okay, so I repeat, for the second reaction, hydrohalogenation, this involves the starting material of alkene with hydrogen halide. But the product, we must follow Markovnikov's rule or anti-Markovnikov's rule. Okay, so what are the difference? Okay, what are the difference? Okay, so here, the halogen, okay, the halogen will attach, okay, the product form, the halogen attach on carbon with more substituent. So we call it Markovnikov's rule. Okay, for anti-Markovnikov's rule, okay, halogen, it must be the opposite. So halogen attach, okay, attach on carbon with more H attached. More H. Okay, more H means less substituent. Okay, less substituent. More H, less substituent. Okay, how do you know whether it has more substituent or less substituent? If the carbon has more hydrogen, means that it is less substituent. Okay, and vice versa. Okay, so now we look at example. Okay, we look at example, yeah. Okay, so whether it follows Markovnikov's or follow anti-Markovnikov's rule. Okay, so now we look at the first, we look at the reaction. So this is alkene, where the double bond here. Okay, now C double bond C, and then we have CH2, and then we have CH3 attached like this. Okay, and then we have H. Okay, so this is your starting material, and then react with HBr, for example, hydrogen halide. Okay, so note the difference. The first reaction just now is halogenation, where your reaction is diatomic, right? There's no H. Okay, so make sure you know the difference. The second one, one is hydrogen, one is halogen. Okay, like this. Okay, so the reaction always occurs on the C double bond C. It cannot involve with other C. It's specifically double bond, okay, because it is alkene. So here will be the substituent. Okay, so when you look at this one, okay, okay, so this hydrogen, okay, let's say this hydrogen, if it attached to the first carbon, this is carbon number 1, carbon number 2, carbon number 3, carbon number 4. So you have to label it first. Hydrogen number 1 attached to, this is not mechanism, yeah. I just want to emphasize on the mechanism. Okay, so like this. So what you need to do is, okay, rewrite again the alkene. Without the double bond. So we draw the structure. 1, 2, 3, 4. Okay, so here we have CH2, CH3. Okay, now at carbon number 1 and carbon number 2, okay, we label it first so that you know. 1, 2, 3, 4. Now originally we have double bond here, right? But now no more, okay, because it reacts with hydrogen halide. Okay, so now where is the position of H? Where is the position of Br? Okay, so if the position of Br is at carbon number 1, Br. Okay, and H is located at carbon number 2. Okay, now we look at the position of alpha carbon. So alpha carbon means the one that attached directly to to the halogen. So this is alpha carbon now. Okay, look at alpha carbon. How many substituent? Okay, how many substituent? It has 2 hydrogen attached. Okay, only one substituent. Which one is the substituent? Okay, which one is the substituent? All of this. Okay, all of this. Okay, considered as substituent lah. Okay, for the alpha carbon. So only one substituent. So we label it first. Okay, now we look at another product. Okay, another product. So plus, yeah. Okay, plus. Okay, again we draw the starting material. Okay, so you have to do it step by step. Starting material here we have 4 carbon, right? So we draw again 4 carbon. Sorry. Okay, we draw again the 4 carbon. 1, 2, 3, 4. Okay, CH3. This is CH2, and then originally this is like this, but no more double bond, right? Okay, now the second one. Okay, the second one. Okay, here Br attached at carbon number 2. Okay, there are two probability. One is where hydrogen attached carbon number 1, and the second one is hydrogen attached at carbon number 2, or the halogen attached at carbon number 1, halogen attached at carbon number 2. So here is Br. So now the second scenario here is that Br attached at carbon number 2. So where is alpha? This is alpha. Now we look at alpha carbon. How many substituent? Okay, so now we look at alpha carbon. How many substituent attached? So now this is alpha carbon. Substituent attached is 1, 2. Okay, CH3. This is CH3. Yeah? So only one hydrogen attached. Okay, so here there are 2 H. So we label it first. 2 substituent, 1 hydrogen. Okay, so which one follow Markovnikovs? Which one follow anti-Markovnikovs? So again read, halogen will attach on carbon with more substituent. Halogen attach with on more substituent, carbon with more substituent. So this is follow Markovnikovs. So we just label. So this is Markovnikovs rule. Okay, rule. So this is anti, and the other product will be anti-Markovnikovs rule. So that's it. That is how you identify it. Remember, the reaction only occurs on the C double bond C. Okay, whereas the others remain, do not change anything. Okay, so there you go. You already produce alkyl halide. Okay, so this. So basically, the reaction in whatever the structure is, you just focus on the C double bond C. Okay, so that's it for the preparation. Now we proceed to the reactions.